be part of the history.
I know, right? Exactly. I will remember this forever.
All right, all right. So we'll be waiting for a few attendees to join. It's almost 5 minutes to the time. So today we have a mix of attendees, some even joining us from London, and we appreciate that a lot. Uh, as well, the program will be recorded as well, so we will share it out there to our attendees and our followers on all our social media platforms. So, yes, let's give ourselves 5 minutes. So I think it's 9:56 here,
Yep.
meaning we have 4 minutes to go live. So, yes, uh,
Good.
in about some few minutes we'll be going live. Right. So I hope you are good at your end with everything. Yeah.
Yeah, no, everything sounds good and looks good so far. Nothing's gonna break down on me, hopefully.
We hope so. We hope so. Everything will go well. Yes. So let me just get back. I'll be going off video. I'll get back shortly. All right. So let me welcome everyone to this AI Back Together 2021 Accra. You are virtually welcome to Accra, Ghana. As we say it, okay. So Ruth, you can stop sharing your screen. Okay, Ruth. All right. So I would like to welcome everyone to Accra, Ghana. You are joining us here, and it's a Microsoft AI Back Together bootcamp, and we are happy to host everyone joining us today. Uh, I'll be your moderator for the event, and it will span for 3 hours. And we have astute speakers joining us today. And In the name of Ankanksha, Malik, our first speaker, our second speaker will be Sarvenan Ganisan. I hope I get the name right. And our last but not least will be Ivana Tilka. So today it's a special day for us here in Ghana, and we are happy to talk about AI. I mean, AI is a trend now, and AI gives you intelligence. AI gives you a smart way of doing things. So I'll not take much time. It's 10 o'clock here in Ghana. So I will give the mandate to Ankanksha to introduce herself. Let us know, let the community know, and the whole wide world know what she is about and what she does, and her passion. So Ankanksha, over to you if you can hear me.
Yeah, perfect. I will steal the screen away and we'll dive straight in, I guess. Welcome, I guess. I'm very, very excited to be here. Like I said a little bit earlier, I am so thankful that you reached out, and I'm very glad to be here today. One thing, Ernest, feel free to jump in if there's any questions or anything. I just can't see the chat because I'm only on one screen today. So I'm just going to mute this down. So just jump in. I'm more than happy to kind of stop and take questions. So let me know if anything's happening or if I'm talking too fast or slow. You know how it goes. Let me know. And yeah, feel free to throw it into the comments. If there is something that's not clear, ask me to go through it again. I'm more than happy to do that. And if I am talking too fast, which can happen at times, do let me know so I can slow down. It's definitely better if everyone takes away something from this presentation rather than me just talking for an hour and nobody hears anything. So yeah, welcome everyone to my session. So yeah, look, my name is Ankanksha Malik, and I'm going to dive in very, very deep and just talk about myself a little bit before I start. So I'm currently based in Melbourne, Australia, which we're almost out of lockdown. Today's our last day of lockdown with COVID-19. So it's a very exciting day here. So close to freedom, but this also just means the fact that we can do things like this now, and I can come and join you in Ghana virtually, which makes it really, really easy. And I really like that accessibility part of it. So I'm a senior data consultant at a Microsoft Consulting Valrada here in Australia at the moment. I'm also a Microsoft AI MVP for the last 2-3 years. Now, I don't even know. I've lost track of time at this stage, to be honest. And I'm a network director for Women Who Code Melbourne. So these kind of things in the community and talking about accessibility and how we can make AI accessible to people is one of my passions, and I really like talking about this kind of stuff. I've definitely done variations of this talk quite a few times, but because it's just makes me so happy to talk about how really easily we can get a lot of people involved in AI. I do a lot of it. So I hope this will be somewhat interesting for everyone today. So let's talk about today's agenda, what we will be covering. We're going to create a model. Actually, we're going to create 2 models with no code at all. So this is for, it doesn't matter who you are, even if you're a data scientist who really knows how to do your Python or R or whatever type of coding, and you can make your models really special and really with built-in AI. Great, you can go do that. It's still for these people who can actually really quickly make models with no code. And for people who've never had to code before in their lives, they can actually go and make AI for themselves as well. And so yeah, that's my agenda for today, to make sure you can kind of see how you can do it yourself and how we can get other people involved into AI as well. So if we think about AI in the market, and Ernest kind of touched on this a little bit about how AI has become so big, but when you think about it, everyone knows these buzzwords where they're like, oh my God, bots, everyone wants bots, or how can we just do like AI assistance or object detection, and like we can do image scanning and facial recognition. AI is just everywhere at the moment, and everyone in like businesses and stuff, they're like, yes, just give us AI. Like whenever we're consulting with clients and stuff, and they're like, we just want AI, and they're like, do you know what that means? Or do you have a problem that you want to solve? Or do you want to just be able to say you have AI involved in your systems? It's really interesting that it's such a weird time for it because everyone wants it. But there are challenges involved with actually implementing your AI solutions. So the people, how are you going to actually create these solutions is important. The people who can build out AI systems and models and machine learning scenarios, There's not exactly every single person out there can do that. So there's a really big talent gap. And then there can be language barriers. And I don't necessarily mean that in terms of languages like English and other spoken words, which I literally can't think of a single language other than English right now, which is terrible. But I mean that in terms of coding languages. So I'm a data scientist. I predominantly work with Python. That's just because that's all I've been exposed to recently with the work I've been doing. But there's other data scientists who only use R. So if you got a data scientist to build out your whole system in R, now you're kind of stuck with only using R as a language, and you're going to have to find other people who can code in R for you to keep going with that scenario. So that's a really big adoption challenge, right? So there's already a shortage of people, and then there's even more shortages because of the specific languages that they can use. The processes, how do you set it up, right? Everyone kind of knows machine learning is amazing, but it needs a lot of data. Where are you going to store it? And if you're going to store it, you need machines. How are you going to invest in those machines? Are you going to buy all of them? How do you manage all that infrastructure? A lot of those kind of challenges come into play. And then the technology part of it, the security of that data. Machine learning is great. You've got all this data, but then you have to think about how safe is that data, right? Everyone wants data privacy, and they want to make sure if their data is going to get used, that it's not being used for nefarious purposes, and you don't want it to go into bad hands. So it's a really tricky place to be in. And then the flexibility part, right? So if you've decided you're going to go with R and you're going to store it in a certain machine somewhere, you can't really move away from that really easily unless that's rewriting the whole thing in a different language or actually physically moving your computers and machines and stuff in the server rooms. So there's a lot of challenges involved. And the point of all this is that, sorry, I skipped ahead a second, but the point of the whole thing is Azure is helping make those challenges come down a little bit with their barriers. And we'll see exactly how that works. So democratizing AI. This is one of my favorite things, which is, again, why I'm here talking about all this. So yeah, this is all around how do we make it really accessible. You don't need to have a $4,000 MacBook anymore to be able to do any specific coding on it because you need a hefty, like, powerful machine. You don't need that anymore because you can just go on to Azure, for example, and rent a machine from them on the virtual cloud. You can do that. You don't need to have a really big storage device or a hardware where you need to store all your data because, again, you can just rent storage from the cloud. So all these kind of steps have been making barriers to entry really, really easy and taking away that step. I mean, I have seen people, I mean, I wouldn't recommend it, but you could technically code and create a AI solution on your mobile at this stage just by using Azure. It's doable. I don't know how easy or accessible in that sense of like coding on your phone is going to be, but if you needed to, you can do it that way. And that's the greatest part about this. And you don't need to have gone to college and done PhDs or learned statistics for 10 years to be able to use these things. They've built it in, and they've built in security in terms of, hey, you're making an AI model, but let's make sure you understand what the solutions mean and what the results are coming back to, and we can explain what this means back to you, and it's not a black box. So that's all of it makes a democratized AI solution, and that's what Azure has been working towards. So the different capabilities that Azure Machine Learning Studio as a service can serve. I was going to say as a service can service, which doesn't really make sense. But these are the different areas and stuff that all the different parts of the service can handle. So if you're a data scientist and you know your code, you're going to dive in and you know exactly what libraries you're going to use, exactly what kind of coding you're going to do, exactly how to break apart all your data. And you know your machine learning, and you know exactly how statistics work and how the machine is going to actually understand this data. Your notebooks are over there. They're available to you in the studio. You can go in and you can use a Python notebook, and you can use it in R. There's SQL language understandability in there. And it's really, really familiar for people who are used to using notebooks in terms of it looks the same as a Python notebook would look like. All that functionality is there for you. Off you go. You can do it. The only extra added thing that Azure can do is it'll give you a place to store your data, and it'll give you machines to use to really power up that machine learning part of it. The opposite end of that completely, if so, for example, you're a business person and you have no idea how machine learning works and you have no coding abilities at all, that's no problem. They've actually got a service called Automated ML, just shortened to AutoML. And what that means is you've got data and you know that there's a smart way around this, that there's a way you can do predictions or future things with this. you just don't know how. You throw your data into AutoML, and I think on my last count, I think it was about 4 different clicks, and you've got a machine learning model going and working for you. So we'll go through exactly how that works. And then the halfway point between the two, right, where you don't really have coding abilities, that's no problem, but you do understand how machine learning works, kind of, in terms of you need a data, and then you need to split the data, and some of it needs to be training the model, some of them needs to be testing the model afterwards on how well it's learned things. So once you understand a pipeline and how exactly machine learning works, that's where the designer is probably the best part. And I'm not saying that a data scientist who can code can't use these other services, right? If I'm a data scientist, I'm trying to tune a model or figure out exactly what works the best takes time. And using things like this can help me actually figure out exactly what I need to do way quicker than me trying to code up really, really big, hefty lines of code. This will take 20 minutes for me to put my data in there, and it'll give me a result. I'm like, oh, that's the kind of thing I need to be doing, and this is going to be the quickest way for me to get there. And then I can start coding afterwards. So it is really built for anyone and everyone. You just kind of go in with your own use case and find what fits best for you. So with that, we're going to focus mostly on AutoML and Designer, because we are talking about low-code solutions today. And we've got data that we're going to go through in demo. So I'm about to jump into a demo now in a minute, and you'll see it all live. Hopefully nothing breaks on me. But today's data set is going to be the Airbnb data set, which is just going to be, I think it's housing in New York. So maybe someday soon, when Australia lets me out of this country and back onto flights and things like that, I might go to New York, and I'd like to be able to predict what a, I don't know, house on Airbnb should look like, and how much should a price for it be, because I'm a data scientist. So I want to be able to do that kind of stuff. I want to see no one's cheating me out of my money, right? And then the other data set I've got that we can have a look through is a secondhand car data set. So if I'm going to go buy a secondhand car, I might run my machine learning model and be like, actually, this is the best price for this car, and that's how much I'm going to pay for it. We'll see how well both of these data sets do in a low-code solution. So we're not going to be hands-on coding anything. This is just going to be, I have data, put it into the model, see what it gives me back. So with that, let's jump straight into the demo. So as I'm doing that, is there any questions? Just checking in. Or I'm not talking too loud. It's too loud. I hope I'm talking loud enough, but I hope there's no questions or anything like that.
Yeah, you are clear.
Perfect. Thanks, Ernest. Okay, so this is our favorite little place, the portal, the home of all my power that I can use everything at my fingertips. I can already see machine learning here, but if you don't have it straight away when you see it, you can always search for it, and you just, if I can type properly, you search for machine learning, and it'll be one of the first things that come up. And you'll want to create it. And this is kind of one of my favorite things about Azure in general. Their user face is really, really kind of similar across everything. So once you've used it a little bit, you'll know exactly where everything sits. So when you're trying to create a new service, there's always a create button up here on the left-hand side. These things do stay very stable and kind of uniform across everything. So it's really nice to see that. When you're trying to create a machine learning workspace, essentially, the studio, all you really need is a subscription where you can pay for what you're using. A resource group, it's usually best to kind of put everything together in one little group so you can delete it afterwards. Please don't leave everything running, because it does start charging up a lot of money. I've got a few going, but I've created one already. So let's just call this a workspace. I don't know, let's call it Ghana Global AI. Everything else will automatically fill in. The only other thing is you might want to pick a region that's closest to yourself. So for me, it's Australia East. I've no idea what one's actually going to be closest to yourselves. Whichever it is, feel free to pick it, and off you go. That's kind of essentially it. That's all you need to do. So you need to have a subscription, a resource group, you want to put everything in one place, and what location you're going from. So I won't create another one because I already have one created. If I could get away from this screen, there we go. Nope, I've not gone away from it. That's fine. So I've created one, and this is, once it's deployed, this is what it'll look like. And here is the launch studio button. You can't miss it. So once you've created it, you can launch your studio, and it brings you to this fabulous place where all your machine learning needs are in one place, okay? So when you think about machine learning, there's two main things. You need a lot of data and you need machines to actually calculate through that data, right? At the end of the day, machine learning essentially is just what humans can do, like our own brains can do, but just at a much larger scale, right? I can look at 10 numbers and be like, this is how they connect, or this is the order they should go in, or that number is a bit of a weird anomaly in there, that shouldn't be there. But I can't do that when it's 100,000 different data sets in front of one thing, right? A machine can look at it all and process it all and remember everything. My brain definitely can't do that. So for the first thing, let's find some compute. And you'll see it over here, and you can borrow your machine power from here. So there's different types of them. And I'll just really quickly explain what they are, because they can be confusing when you first start off here, right? So a compute instance essentially is just you borrowing one machine. So it's just, I've got a laptop here, it's got a memory in there, it's got some RAM power, everything in there. Don't ask me to explain what the different things are because I can never remember. But that's what essentially an instance is, just one different type of machine that you're borrowing. So there's different levels of them. Feel free to go pick whichever you'd like, and there's costs associated to them at different prices. So if you get a really hefty one where it can do a lot of work in one go, as you can see them, the 14 gigabytes, 28 gigabyte RAMs, there's different levels of them. And you'll see the price goes up and down based on that. Pick whatever you want in terms of, if you need something really, really big, like a really big data set you want to push through really quickly, you might aim for a really big machine. But if you want something that'll just kind of get the job done whenever it does it, you might go for a smaller one. It depends on your own needs. Pick one, and then it already kind of gives you a random name. If you need specific naming things, you can change that, and that's it. And you'll hit create, and it'll go do that for you. So that's an instance, so that's just one machine. What if you've got a really big workload and you're like, one machine, doesn't matter how big it is, it's just not going to cover all the work, and I'm going to need it to go up and down. So if I get a lot of data, it'll just do a lot of work. You can create clusters, and what a cluster is just multiple machines working together to solve your problem. So again, it's the same process of creating this, and you can pick whichever one you'd like. Give it a name here. And the nodes is how many different machines you want to join up and work together. So always put your minimum as 0, so that when it's not being used, it'll go back down and say there's nothing being used. And you can go up to your maximum of whatever you'd like. I definitely don't have enough 5 nodes in my subscription. You can only have certain numbers, but you can go up and down as much as you want. I've already got one created, which is why I can't go too high at the moment. And make sure you do scale it down. So if your machine isn't being used, so you can set as many like seconds or minutes or whatever you'd like as your timer. If it hasn't been used in 20 minutes, shut it down for then, right? Those kind of things, just so that you're not getting charged for what you're not using. And that's how you create a cluster. I won't create one again because I've already created one. Click out of that one. So I've got a cluster here with 3 machines joined up together, and they can work together if there's enough work to be separated by them. If there's only work enough for one machine, it'll use one. If there's loads of work, it'll use all 3. That's the scenario of a cluster. And an inference cluster is a Kubernetes service, and this is for when you're trying to deploy your models across to kind of an endpoint, like an API and stuff, where you can use it further on into your apps or anything like that. That's where you might need a cluster, and we'll talk about that when we actually need it. But again, it's fairly straightforward in terms of creating a new one. You pick your location, Australia East, and you pick what machine you want.
Hello, Ankanksha. So, I want to ask a question.
Yes.
I wanted to ask, how do you quantify your data to know that, okay, you need 2 instances or 3 instances? How do you go about it?
Good question. I have never actually thought about that, to be honest, would you believe? And that's mostly just because, okay, I have and haven't. When you're dealing with data, I actually really don't know how to answer this question now that I think about it. How do you know? Honestly, trial and error has been my answer, is why I haven't really thought about it. When I'm at work and I'm using kind of data sets which are terabytes of data, where there's like 100 gigabytes coming in a day, that's a case of, you can see when our cluster fills up, we can see how busy a cluster is at work really quickly, and that's on a different system. But when we see that, we're like, oh, okay, we might need some more, we'll add it in. If we don't, we need to stop some works happening. But in these scenarios, mostly, especially in the low-code solutions, it's usually everyday people who are looking to get a really quick answer to what their problem is. Or even if it's a data scientist doing something, they're just trying to sample a small part of their data set to get an answer of what they're doing. So you never really need a really, really big solution here. And if you did, that's a case of like, okay, if you're dealing with like 100 gigabytes of data, you're probably experienced enough to figure out exactly how much compute you need at that stage as well. And if you don't, test it. And if it says there's not enough and it's taken too long, you keep adding it in.
All right. Okay. Good.
Okay, cool. Perfect. So that's our machines. So we said we need two things for machine learning. We need machines and we need data. So let's go find some data. And there's different ways you can attach data. I've got a few sample ones already created here, but again, everything that you want to create, like in Azure, is on the top left side. So we want to create a data set, and there's a few different places you can connect a data set to. So local files, if you've just got a file sitting on your machine, which I do currently, and I've got a CSV, so let's call this the Airbnb dataset. And it's a tabular data because it's a CSV. You can also just upload a file, but most people will be using a dataset which has numbers and it's in table format. Where do you want to store it? So when you create a machine learning service, like we just did, it automatically creates different storage solutions for you. So you can actually, on its own, go and put it in the right places and file everything away for you. But let's upload a file. This one, I've got a CSV. I'm like, yep, okay, that's the one I want. Upload. It takes a couple of minutes because it's a fairly small file. So I think it's about 10,000 rows in there. And it'll parse it and make sure everything looks right in there. And this is what it'll give you. It's just a quick sample of your data. So my data set, again, like I mentioned, is the Airbnb. So this is what it looks like. There's neighborhoods, the big boroughs in New York City, the actual neighborhood, like the smaller ones inside them. What kind of a room is it? Maybe it's just a room or the whole apartment. And the assumption here is, right, the whole apartment is going to cost more than just the small room. Things like that. You kind of want to start thinking about what's going to influence the price, because that's what we want to predict, the actual price. How many nights can you stay? The number of reviews that property's got. How much availability does it have? So is it someone's house or is it just a rental if it's available all year? Different things like that. So that's what the data set is. And here you can kind of make sure that the delimiters are correct, and you can choose different delimiters in terms of the file format you have. If you've got headers, let me hit next. And here, this is what it's kind of cool, right? So you can pull in different parts of your data. So if you didn't want specific columns, maybe I don't want the ID and the host ID because I don't think they're going to do much in terms of predicting my data, I can remove those, and it doesn't delete anything from your own data set. It's just the version of the data that it will store in Azure. And you can pick and choose, make sure the type is correct. I don't think I've ever really experienced the type not being correct on Azure. It's pretty much perfectly picked up every single time. If it was, though, feel free to change it to a different type. And next. And this is just confirming all your details, that it's going to go be saved in the right place, all the etc.s, and you hit create. Sorry, I'm just not hitting create because I've already created multiple versions of different things. But sorry, I just want to point out a different thing as well here. So from data store, if you've already got your data sitting in Azure, it's really, really easy and quick to actually connect things up from kind of your data itself. Because it's somewhere else. So whether that's, let me just type it in here so you can see it. I don't have any at the moment, which is why it won't show it really quickly. But if you've got anything in your kind of blob stores, file stores, all of that's connectable. If you want to create a new data store, you can do that too. And you can use your keys and storage authentication keys to connect things up and make sure everything's authenticated and you're not stealing someone else's data and it's secure and you don't need to put more passwords in and all those kind of things. So if you've already got your data sitting in Azure, it's really easy to bring it into Azure Machine Learning and actually leverage that to be able to do your machine learning on top of it. And the last thing I want to show you from here are the open data sets. So you want to do machine learning, you want to learn about machine learning, but you don't have the data to actually really test it out. And there's actually sample data sets that Azure has that you can pull in from. And these are data sets that are like huge. I mean, millions of rows kind of big. So you can really kind of test things out and play around with it to kind of get comfortable using Azure before you have your own data you want to play around with. So feel free to have a look through these, and it's really easy to actually use these. So let's say for the New York taxi example, that's a big data set, and you just filter on kind of what level of data. Maybe you want 2 months of data, you can pull 2 months in, and it'll create a data set for you that you can then use in the service itself. So it's a handy little thing to use if you want to test things out later. Okay, cool. So I've talked about machines and I've talked about data. We've got the 2 main things we need. Let's jump in and let's go through some examples of how this runs. So automated ML, like I mentioned, it's the one where you just throw your data into it and it'll start making a model for you. So we're going to use the Airbnb data set here, and I've already created data sets, so they'll pop up. I can create new ones from here as well. So let's just pick one and I'll go through exactly what those ones are. So the columns drop data set just doesn't have the ID and the host ID at the front of it. The next thing you need to do is create an experiment. And all this means is just all the different tests and stuff you do, all the different runs and times it kind of goes through your data and learns again and again. It just keeps it stored. It's almost like a resource group for your different tests that you'll do on this data set. You can keep it all together and you can kind of delete them afterwards if you don't want them. So I'm just going to select one that I've already got here, Airbnb. What's my target column? What do I want to predict? What do I want to actually be able to put machine learning against? That's price. I want to predict the price of what my property, or how much should I be paying for it, I guess. And it'll tell you what kind of compute you need. If you don't have one, you can kind of create it directly from here if you didn't create it at the start. I've got one going, so let's just click that. Next. And then there's 3 different types of machine learning it can do on AutoML. So classification. And I'm kind of just reading off the screen a little bit, but it explains it really, really well. So classification is obviously those kind of grouping things of, is it this or this? Is it a yes or a no answer? Is it a red, blue, green? However many categories you want. Is it based on the maybe census data, all these different information about a person? Are they going to make over $100,000 or under $100,000 based on the fact that they have a college degree, or they went and studied this, or they have a car? All these different things. You can use that kind of a classification, or you can use regression to predict specific numbers, which is kind of what we want to do. We want to predict the price of a house based on the features like where is it, what neighborhood, how many rooms does it have on rentability, and how many reviews has it gotten in the past. Is it, I don't know, 5 reviews worse than maybe 100 reviews? What's the price difference? And you can also do time series forecasting, which is kind of predicting on Sunday, is it going to be more expensive than, or maybe on a Wednesday in the middle of the week. So that's including time as well. And that's essentially it, right? All I had to do was give it my data, put some machine against it, and say, this is what I want you to do with it. And all I have to do is hit finish, and it'll start actually creating a machine learning model based on my data. And what actually happens in the background is what Microsoft has done. There's a lot of data scientists that work there, and they sit down and they've created, I think, like hundreds and hundreds of different models. That basically what this whole thing is going to do now is use my data. It'll run all the different models on top of it, and whichever one comes out the best, and what do I mean by best, is best in terms of my metric. So I want to calculate it in terms of root mean squared errors, and whichever one has the lowest root mean squared error is the best model, right? So that's what it's going to go do. It'll go run through all of that, and let's see what it looks like once it runs. So this one finished, and it had a normalized oh my god, I really can't talk anymore. Normalized root mean squared error of 0.02. And this, it said, was the best model, was the voting ensemble. And you can actually see all the models it runs and what the best metric was for each of those. And there is a lot of models that it actually tested out and went through as it was doing that. A lot of them come close, but obviously one of them is the best. And that's what it gives you back. And you can see an explanation for this model. What does it actually mean? So let me get that loaded up. And what it can tell you is what's the feature which was the most important in actually predicting the price. And it says the room type. And you know what? That kind of makes sense, right? Your assumption is always, it doesn't matter where, in what suburb it is, the the price of one room in an apartment is going to be way lower than the price of a whole apartment on rent, because then you've got multiple rooms and services and etc. etc. So you can't expect that. And then the neighborhood group also had a really important feature on it in terms of, is it Manhattan versus Brooklyn, those kind of things. Is it closer to the middle of the city? How available it was apparently was really important. So there's different things you can test out and mess around with to figure out exactly what's the most important feature involved in this. Feel free to kind of go through different parts of it. I'm just going to go into here. So if you deploy a model, what does that mean? So deploying a model essentially is just a case of, I've got this data, what do I do with it? How do I actually use this in real life? And you might have an app that you've built where people can kind of go in and be like, I'm looking for an apartment in Manhattan for a room on its own. What's my expected price based on that information, right? How much should I be expecting based on all the things you put in? So those kind of things can be deployed and integrated into your apps, and they're integrated through APIs. I am not a developer. I am not an app developer. If that's you, I'm very excited for you, because then you can connect your API into your app. But all I can show you is what does that endpoint look like. So if you hit deploy, it'll create an endpoint and it'll look something like this. And there you go. People can go through and figure out exactly how they want to attach it to their websites or their apps. It's just an API call it'll make. And you can test it out in different levels as well, or you can consume it and it'll give you a JSON editor of what the output should look like. There's different ways of kind of figuring out exactly what you want to do with it. So that's how AutoML works. And again, all you had to do was have a machine that you were able to borrow from Azure data, which you had yourself, or you can store it on Azure if it's a really big one. And then you clicked, I think it was like 3 more clicks after that, and choosing what kind of machine learning you want to do and saying go. And these runs usually take about 30 minutes, I think. Yeah, all of them have taken 30 minutes for me. And that's based on like a normal enough machine that I've borrowed off of Azure. And what I did was, the first run that I made of this data set, that was a full data set. I'll show you very quickly. If I could find a data, that would be a good start. No, I can't remember where it was. So, God, I actually completely. So they keep updating things on this, and I keep forgetting where things are sometimes. I'm like trying to look for different versions of it. Input data sets, is that where I'll find my thing? Explore. Will this show me my data? I will hope it will show me. Yes. So, oh, that took a while to get here. But the first time I ran the model, I put the whole data set in, and I was like, see how well you do. Tell me what you find important. And once I did that, I was like, oh, actually, I feel like these are just random numbers in terms of the ID and host ID that don't really mean anything. They're just identifiers for what apartments were, right? So I'm like, I'll get rid of those. So I dropped those 2 and reran the test based on just the rest of the columns. And what I came back with was like, let me show you what I came back with. Nope, this button here. So once I dropped the columns, I asked it to explain it. And what I found in the explanations was, well, these are the best features, right? The top 4. Maybe let's look at a few more. So these are the best features, the first 5 really. The other ones kind of just filter down. So then I just reran the whole thing with the top 5 features in my data set, and that's the last one. Look at this run. And this has come back with a different algorithm because it's quite succinct in terms of, I just want these 5 features and predict the price from it, see how close you can get. I can't remember what the other numbers were. They look pretty close to 0.02. Can't remember if they got closer, but that's just different ways you can kind of test things out within AutoML, just giving you a quick idea of it. So that's one way of doing a low-code solution using AI, and the other one is Designer. And this is where you can drag and drop different things. I'm just going to take a quick second. Ernest, I know if I've got, how long have I got left? So I know it's, you said about 45 minutes, so I've got about 10 minutes.
Actually, you have an hour, so you can go
Oh,
ahead.
an hour. Perfect. No, I was just testing how in depth I want to go. Perfect. I'll go and do it from scratch. So the first thing you're going to do is attach it to a machine. Oop. I've got one running. It's attached. And that's what it's going to use to actually run this model when I create it. So we talked about the second data set, which is going to be my secondhand cars. All the ones I created already, I can create another model on my Airbnb data set, but let's do a sample data set this time. So let's do automobile car prices. So these are different pricings for different cars. And let me show you what the data looks like really quickly. So this data set has different things in there, like the make of a car, what kind of a fuel does it take, how many doors does it have, how many, I thought that was on drive wheels. I'm like, how many drive wheels does it have? It's just what kind of a drive does it have, cylinders, engines, there's a lot of detail, horsepowers, I don't even know what those things mean anymore. But what my important one is the price. And the price is important in terms of that's what I want to be able to predict afterwards. So based on all this other information, such as number of car doors and how many wheels has it got, I don't know how important each of these is going to be, but I want it to use all that stuff to come up with the final price of how much a car is worth. So let's push this back here. Get rid of that. So I've got my data set. And even as I was looking at those outputs, some of those columns didn't really make sense, right? They're like, I mean, why are they here? It's kind of like that Airbnb data set, the IDs and all those things. You don't need those, not all the time. So normalized losses, like there's a lot of NANs in there. I don't really want that column. We can get rid of that. The others kind of seem, I'm like, okay, they might be important. So I'll keep the other ones in and I'll just get rid of that one. So I want to push this back first. And I want to do select columns in a data set. So we can drag that one out. I don't want all my columns, so I'm going to select different ones. So I want to include, actually, let's include all of them to start with. And I just want to get rid of one. So we'll exclude a specific one, which will be normalized losses. So now I've gotten rid of a column from my data set. I maybe want to make sure that there's no missing data in it, right? I want to make sure it's a clean data set that I'm putting through here. So we can clean our data, clean missing data. So these arrows essentially is just connect everything in, right? So this is my data that's connected here. Now this next step is this one. It's just one by one. It's just making sure the flow of the data makes sense. So what columns do I want to get clean? Well, actually, I want to make sure all my columns are pretty clean. So let's say all. And if the value of ratio, blah, 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 I mean, usually you want to substitute your values. But, and I mean, this is not the best way of doing it, but for now, just to make things easy, I'll just remove the entire row. If there's a missing data in one of the columns, I'll just get rid of that row for now. The best way is usually to kind of calculate a different version or figure out why it's missing and replace numbers in there. Just for the sake of today, let's just get rid of it. So now that I've got clean data, and you'll see there's two outputs, right? So one is going to be what I've asked it to do, which is clean the data. The second one's kind of the leftover stuff. We don't want that leftover data. So we've cleaned it. And usually when you're doing machine learning, obviously when you've got your data, you want to train your data. So you want to show it's like you're going back to school, right? For 3 months in school, you learn something and then you're taught it based on maths and stuff, all these different things. And at the end, there's a test on things you haven't seen before necessarily. It's completely foreign and you get tested on how well you understand the things. Exact same thing with machine learning. We're going to teach it some things. So let's, nope, I don't want that one. I want to do a split. So we're going to teach it some things, my bad. So we're going to split our data. One's going to be used for training, one's going to be used for testing. And usually you kind of split it based on how big your data set is. You'll kind of look through your data and figure out a good enough number for me at this one is like 70%. So I want to train it based on 70% of my data. So I'll say 70. And the rest of the 30% is going to be used to test how well it learned based on that data set. So the first one is going to have 70%. The second dash is going to have the 30% of the data, because that's how you split it. And then I want to train it. Let's say train the model. And so I want to push it to here, but it won't let me. It's making me force it into this one. So what goes in here? It's going to be, you want to train your model, but you need to train it using an algorithm. So we can go in here and actually go through all the different algorithms that they have created for us. And a really easy one is linear regression, and we're just going to test that one for now. But the handy thing about Designer is all you can do is create multiple different pipelines to test your data against loads of different algorithms and see which one comes out the best. And then you can kind of actually be like, oh, okay, if, I don't know, a neural network regression is the best kind of option for that specific data set, then I can start going into notebooks and coding up a solution for myself as a data scientist if I needed to. But it's just an easy way to kind of test out your data as a data scientist, or if you don't have the coding experience, this is a great way to actually set up a model for yourself. So let's train this model using linear regression. I'm going to use this as the data, because again, you need an algorithm to actually learn how to figure things out. And once you've trained it, oh, it's got a little red arrow. What have I missed? What do I actually want to train? Like, what do I want to predict? And I want to predict price. Where is price? There we go. So it's pretty good in that sense of it won't let you skip things, or it won't let you forget anything. It will remind you that you've messed up somewhere, which is kind of needed at times. Then we want to score the model. Basically, no, we don't, do we? Sorry, my screen has just frozen. Give it 2 seconds. Everything's kind of going blurry for me. That is being weird. Okay. I think it's coming. Okay. Can you see the screen?
Yes, we can see the screen.
Okay, cool, perfect. So, my bad, you don't score the model, you evaluate the model first. So, you've trained it. Oh my God, I'm losing my mind. Yes, you do score it and then you evaluate it. Sorry, ignore me for the last minute of my life. So, you've trained your model, and now we want to score it, right? So this is like, again, how are you going to score your data? Back in school, a teacher sits down, gets your results, and puts it against the actual things. So we score it with the 30% of the testing stuff. So in the training part, it went and learned everything it could from there. And now the scoring part essentially is just actually testing the algorithm and seeing how well it fit all the data to it. So that's where we're going to put the 30% of the data against it and be like, let's do an exam. And once it's done the exam, we want to evaluate how well it did, right? Now that you've tested, we want to actually go and do the checks of, okay, this was really close, this was not that close, how did you do? And once you've evaluated the model, where's the button? Okay, perfect. There we go. Sorry, they really have moved things around on me. I'm very sorry. The last time I looked at this was about 2 months ago, and they've literally changed a few bits around. So when I score the model of this was my actual price, and this is what my model predicted it as, where do I want to see those? I want to see it appended to my actual data. Just add another column. That's what this one is. That's what I was looking for. You can append it, and it'll just add it saying, this was the actual, this was the predicted. And that's it, I promise. There's no more confusing and me getting lost in my own data set. But that's a pipeline. It took about 10 minutes to create that, as we just went through. And that's kind of it. And I think the really cool bit about this is a little bit more customizable than AutoML. In AutoML, you can't really customize anything other than being like, well, I want the best model for X. This is my metric, figure out the best one for this. Whereas in this one, you can actually move things around in your data set. You can just kind of tweak things. You can try it with a lot of specific different types of models. Like I showed you a few there. So there's quite a few for regression, the clustering, classifications. There's loads of different types of models. And this is becoming a little more niche with your data set, where you can test and see what works, what doesn't. And the other end is you can actually put code in this as well if you wanted to. So you can actually create Python scripts within this drag and drop model to do really, really specific things somewhere within your data if you wanted to. There's a lot more customizable in that sense and there's actually adding in things like text analytics or computer vision and even anomaly detection. So if those are the kind of data sets you want to use, you can actually do that through this, which at the moment you can't do on AutoML because it's only classification, regression, and time series on that. So that's the difference between the two. That yes, this takes a little bit more time because you have to kind of set up every single piece of the puzzle, but it's giving you the power to change every piece of it as well. So once you've done that, you hit submit, and this will go and run this whole thing. I will show you what it looks like when it does finish that, just because it'll take time and I don't want to waste your time today. So once you hit submit, this is what it looks like. It basically goes through and runs every single step. And let's look at the score model. Let's look at the output. What did it give us? And this is where we asked it to add in a column that was the predicted price beside the actual price. So the price for this car was, the actual price was 9,639, and our predicted price is saying that it should be 10,900. And if our model is really, really great, we might really believe it, like, hey, this is a good deal, right? I should buy this car because it's coming up about $1,000 cheaper. And we can keep going, and this one's kind of like, according to the model, this one's saying that this is a little bit more overpriced, so on and so forth. So it's up to yourself of how well do you believe your data. But if I go back into this, there's all the different parts of this, like the details of how long did this model run to compute, and all these kind of different things. But metrics, why do I not have metrics? I will put them in later. Oh, I think I didn't click. My bad. I forgot to hit like yes for explanations of reviews on this one. But it's exactly the same in that scenario of once you've created your outputs, you can have a really quick look, figure out exactly what you came out with, and see how well your model suits. And then you can create an inference pipeline. So this is where the deployment happens. You can click deploy on your pipeline, and then you can create a real-time inference pipeline. So this is exactly the same as the AutoML option, where you want to deploy your model so you can use it in apps and websites and stuff like that. And it's the same clicking buttons of create pipeline, deploy. And it brings you down to a page like this, where it gives you a REST endpoint that you can then go connect it, a Swagger URI as well. I just figured out what Swagger URIs were a couple of weeks ago, and I was like, oh, now it makes sense. I've been looking at this for 2 years, but never had to use them before. But you can actually go test it. So let's actually do a test, right? So if these are if, for example, you had a car, an Alfa Romeo, it had a gas fuel type, all these different things, the length of it, you actually calculated it exactly down to the millimeters. You put all your data in, and then you say test. It'll run that, and it'll give you what a predicted price was based on the model that you've created. So when you connect this into your app, it's the exact same thing. You can ask for inputs, send it through the API, and the API will return a scored number, which will be the predicted price, back to you in your app. So I hope that makes sense.
Okay, I want a question.
Yeah.
I wanted to ask, in all these, how do you manage precision and, let's say, accuracy in your predictions? How do you manage it?
Good question. And that's a question that I kind of think about all the time. And the easiest answer, to be honest, is for using, where was it? Things like the explainability. My God, I'm losing. There we go. So for me, the way I found it to be the handiest is going in and being like, okay, so this is the model that came back, and these are the most important things in this model. Let me try to rerun this with just the important ones, like the feature selection in a way. Or you can actually check the different levels. So, I mean, if you look at it in terms of kind of an explained variance, it's very low variance for this model. So you can keep testing things out, and that's essentially what machine learning is at the end of the day. It's just you keep testing different things out and seeing which one comes back highest or it comes closest to what you'd like. And the other thing with an AutoML, right, when you're creating it, I can't remember if I'm here next. Just give me a sample so I can move on for now. So here, what you can do is actually see configuration settings. I can't remember if I went through this, but you can choose what one you want to do position on or which one you want highlighted. So basically, if you want to really kind of narrow in on the R-squared score of like really like how is the variance being explained and how closely are we predicting it, pick that one, run your model, see what features are the most important, pick those features, rerun the model, see how close you get your R-squared, tweak more things, see what's in your data. And this then comes back down to like data science, right? You're trying to figure out exactly what's happening in your data. Is there missing data involved? Do you want to clean your data set? Do you want to make sure that there's no faulty errors of values in there? Clean data is impossible to find, not just back because there's values missing, but also because there might be error data sets in there, right? So in case of, let's say, the neighborhoods, there might be a neighborhood in there that doesn't even make sense or isn't even in New York. Have you checked that correctly? So those kind of things you start looking at to make it a better like data set to be actually carried out in machine learning. Does that make sense? It's a lot of trial and error.
Okay, so I saw Muhammad Keita, you raised your hands. Do you have any questions? Hello, Muhammad. Okay, I think we can go on.
Okay, cool. And I've just read the comment there in terms of the fact that you are a developer and you can export all this out. Perfect, exactly. Let me show you what the notebook scenario looks like. So once you've got the code, you can actually pull out the code, whether it's in Python. Python's the most supported stuff on this. There is our capability too. It's just not as good as Python is at the moment. But if I created a notebook, for those who've used notebooks, it's a very similar kind of context, right? I mean, print, let's say hello, and it runs it because it's already connected to my compute. I can connect it to a different one if I wanted to, or set up another one, and I can make this markdown cell and not make it a right actual kind of markdown in this. Previews. Ooh, sorry, there was a new feature in the other one that I was looking at. Oh my god, why can't I type? Oh yeah, there is preview, which I find really handy when I'm. Okay, maybe I can't write markdown. Anyway, I thought the double ones meant different headings. Moving on. But the point is, it's really, really handy. And it's actually now started inputting IntelliSense into this as well, which is just absolutely great. So as you're going down coding, it all links up and everything makes sense. You can open it up in VS Code directly from here. So if that's a preferred scenario for you, off you go, you can use it there. And I think, Ernest, did you ask about like, when do you know your compute is enough? So in the context of AutoML and kind of Designer and stuff, you'll just be like, oh, this is taking a bit too long for me. Let me bump up the machine power. Here, you can actually see how much of your machine is actually being used at any given time. So if you can see it getting really, really close to the end, like 95%, you might need a bigger machine or a bigger cluster in that context. So when you're actually fully coding, you'll start seeing those kind of things. I hope that makes sense. But overall, that's kind of everything I wanted to go through today, I think, in terms of how you create a compute, how do you borrow some machines in the one studio, how do you set up your data sets, have multiple different ones connected from anywhere you'd like, how can you run an automated ML model, and then how can you run a designer model and actually deploy them and have them ready as API endpoints for them to be used in other places afterwards. So I hope that made sense. And if you have any questions, let me know.
This question here also. So some attendees wanted to know, how do you get started with all these things that you've spoken about? How do you get started about machine learning?
Yeah, no, so honestly, just start playing with it. Do kind of what I showed you in a demo. You can sit down and literally do that for yourself. Set it up, get going. Let me show you the docs on this. AutoML Azure Docs. So if you go in the automated ML, or I mean, the designer has their own docs as well. You can actually go to, and there's how-to guides for everything, and how do you train models, and how do you deploy models with all the different versions. And they literally go through step by step of how do you do everything. And and this is kind of explaining everything within it, what the different things, metrics mean, what does it all mean, how do you use it, what does classification, like all of that kind of stuff is really well explained. Honestly, jump to the docs and then follow it. And the best way to do any of this is just start doing it yourself. So like I mentioned earlier on, what you can do is go into your data sets. If you don't have data to play with, there's open data sets and sample data sets really easily available that you can connect to and use that to actually build out your own, build out your own models from there as well. Oh, I just clicked OneNote, which I really shouldn't have done. I went to go back to Meet and my Teams.
All right, so we are taking questions. You can raise your hand, and then we allow you to ask your questions. Ankanksha is still here with us. So attendees in there, we have about 5 minutes we can use for questions. If you also want to post your questions in the chat box, you can rightly do so, and then we will take it up and ask Ankanksha. So yes, I think it has been very insightful section. I like the demo that you did predicting the price. It was very cool. It was really cool for us.
Yes, I hope it made sense. There's bits where I was getting confused, like, what am I talking about? But I'm glad it made sense.
Yeah.
Machine learning where nothing ever really makes sense at times.
So, yes, we are still taking your questions. Muhammad, if you can hear me now, I saw you raising your hands. If not, I think it's been very insightful section. We've had 2 demos, and one actually came out just on the go. So, I mean, it was very insightful to get it. And we now know where we can at least start to play with our various kind of predictions and modeling and what have you. So, I mean, Ankanksha, can you also display your handles? Maybe they would like to.
Yeah, for sure.
Yes, so that if they have any other questions after this program, they can reach you.
Yeah, so my Twitter is up there, and that's the same for my LinkedIn as well. I should have probably written them up, but Twitter is probably the easiest place you'll find me. All my things are usually there. LinkedIn gets a little bit full of people messaging at times, but yeah, reach out. I'm more than happy, and especially if you try things out, like tell me you tried it. Like I get so excited when people go and try these things. They're like, "Hey, I tried what you talked about." I'm like, it makes my day so much better. So I'm more than happy to help if you do and are looking for anything else.
Yes, that will be wonderful. So viewers out there, as you heard, just try it. Let Ankanksha know that you tried his lab demo and it also worked for you. So yes, thank you very, very much, Ankanksha. And as you said, today is your last day in Australia, right?
Today's our day of lockdown. Yes, the end of lockdown, so we can go outside tomorrow.
Okay, so, I mean, enjoy, and we are very happy to host you today. Will you be around, or you will be going out of the meeting? So
it's getting close to 10 p.m. here, so I might get ready for bed, to be honest. But I will try and I'll have it playing in the background, I guess. But yeah, I might have to drop out soon enough. But I'll be here if there's any other questions or anything for a little bit at least.
All right. So thank you very much, Ankanksha. And as we move on to our